Hello fellow problem solvers. So today we're going to be doing a problem from the 2013 IMO shortlist, problem number N1. I suggest you try this nice functional equation out for a minimum of 10 minutes, ideally 45 minutes, but not more than 2 hours. If on the other hand you'd like to go along with us, put your first ideas out on paper for the next 10 minutes. So now, let's begin. So the problem we have to find is a function from the positive integers to the positive integers such that for any mn which are in the positives, m squared plus f of n divides m times f of m plus n. Now, the first thing for me here is f of n equals n is a solution, because then we have m squared plus n, m squared plus n. And now, what can we do? Let's plug in some stuff and see what happens. So also we can play around with this. We can make this side a lot of things, perhaps not everything, but we can make it a lot of things. Just like the first thing I see. And oh wait, actually this side we can also make a lot of things. Okay, so now there's a lot of ideas you can get here, but the first thing to look at is what can I make of this side and of this side. And for me, I was looking at this side. I'm thinking of primes. When you have divisibility, think primes. It's a good rule of thumb. Sometimes they're useful, sometimes not. But it's a good sort of pattern to try. And for me here, I just want to try set n to be equal to a prime, a big prime, minus m times f of m. And then what I have is m squared plus f of p minus m f of m divides a prime number. And now, this is actually very much constrained. Like, what numbers divide a prime? 1 and itself. So if p is greater than m times f of m, and we can always pick a big enough prime, then we know that f of p minus m times f of m, like this plus this, it can't be 1, because this is at least 1, this is at least 1, so this sum is at least 2, so it must be equal to p. So now we know that this is equal to p minus m squared. And yeah, so whenever p is a prime greater than this, we know this. It's something. We have not a solution, so to speak, but we have a couple of numbers covered just off the bat. Just by asking the question, what can I make of this problem? Like, what can I make of one of the sides? And now with this, I invite you to pause for another, 5-10 minutes and push the problem further. See what other ideas you come up with. And here's the next step for me. So we have m squared plus f of n divides m f of m plus n. Now my thing is, okay, let me see what happens when I plug in m is 1. Then this side, is limited, this sort of limits what f of n can be. So what do I have? I have f of n plus 1 divides 1, actually no, f of 1 plus n. So now this sort of says that f of n is at most n plus some constant. And this constant is fixed. This constant is f of 1 minus 1. We know this. So I have a bound on what f of n can be. And now maybe it's useful here. Now I know that, say, this is less than or equal to f of this. So this is n plus a constant. This is p minus f of m plus some constant. The p's cancel out. I have m f of m. Okay, I do not get anything. I thought I was going to get something, but it turns out not today. Actually, wait a second. Do I get something? Is the constant now smaller? So if I divide by m, I get f of m is less than or equal to m plus a constant over m. Maybe this can always decrease my constant. Maybe as m is large. Maybe there is something to this. Who knows? Actually, if I've done everything right, it means that as long as, if m is greater than this constant, i.e. if m is greater than f of 1 minus 1, then we know that f of m is less than or equal to m. So it really bounds this part very, very nicely. And, okay, so can we use that in any shape or form here? Like how this is bounded. This is bounded. So what do we have from that? Do we have anything or not? Who knows? But now with that, I invite you to take another 10 minutes and push the problem further. Here's my next step. And now there are a lot of ideas that you can go by. and try to push and prove. Now, one way of thinking about the problem at this point is to say, okay, f of m is sort of like limited. Now, if this thing isn't equal to this, then, I mean, if it's equal to this, it seems like maybe I'll be able to solve this problem very quickly for some maybe mn pair. But if it's not equal, what do I have? I have that this, at least twice of this, 2 times f of n, that this is less than or equal to m f of m plus n. And now with this, mind you, keep this in mind, we have that, what I have, m f of m minus m squared plus n minus f of n. Again, this is going to be greater than or equal to m squared plus f of n. Now, maybe if f of n, like, hey, if n is a fixed number, say, a small fixed number, then this is going in the positive direction. Now, this is positive. But this thing right here is going in the very negative direction. If for some large number m, we don't have f of m equals m, whatever large, we later define the large thing. If it's not large, then we'll have that this thing right here will be a contradiction, because this will be at most m times m minus 1 minus m squared, i.e. this will be at most negative m. Mind you, at most, when I mean at most, I mean this is going to be negative, and it's going to be negative m, or negative 2m, or negative km, a lot of m's. And this thing right here, we can sort of bound, you know, we can say like this is going to be greater than or equal to n. But this needs to be greater than or equal to something positive, which will be impossible for some m. So now maybe that's something to work on, to think about. And that's one approach. Another one is say, hey, I don't have enough information just now. Let me plug more stuff in. Let me see if I can get any values. I haven't gotten anything so far. So let's see. If I plug in, say, I plugged in m equals 1. What happens when I plug in n equals 1? I get m squared plus f of 1 divides m f of m plus n. And this plus 1, actually. And now this is less than or equal to this. Can I have anything here? Actually, wait a second. Does this sort of... we have this is greater than or equal to that. So we have m f of m plus 1 greater than or equal to f of 1 plus m squared, i.e. divide everything by m. And now we have m plus f of 1 minus 1 over m is less than or equal, is greater than, like this. Actually, plus or minus? I'm confused by now. Like, now, is this good? I invite you to take 5-10 minutes and figure out if it's good or not, if I made a mistake, and maybe even push the problem further on your own, because now I'll be getting to an actual solution. But before I do that, let me give another sort of thinking of what we could have done. We could have said, hey, I have f of n here. Let me make f of n on this side. So I have a divisor. And now if I plug in, say, m is f of n times something, some constant, some k, that's a variable, we'll have f of n times k squared plus 1 divides f of n, f of n plus n. And now mind you, f of n divides this, so f of n must divide n. And now this is basically done, because we have this on once. Actually, no, it's not done. We have this thing right here, and now we know that every f of n is a divisor of n. And now the question is, how can you use this? Can you use this in any way, shape, or form, taking into account what the problem is? And now with these bunch of approaches, I'll start combining them and write up some solution. Here it is. So one way of going about this is figuring out what we did before, plugging in this thing, and getting this. And now, mind you, think about this. This is some small difference. If you get p large enough, this will not hold true. And the way to really do this implies that p minus m squared divides m squared minus m f of m. And now, this thing right here is constant. This grows without bound. So this implies that m squared minus m f of m is equal to 0, i.e. f of m is equal to m for every single m. So just like, for any m, we find a huge prime such that this is just absurd unless this is 0, and we're done. Another way would have been to put in n is equal to m, and then what you get is that n squared plus f of n divides n f of n plus n. And now you want to work with this somehow. Oh, what do? Well, you have n squared plus f of n. You see this divides n f of n plus n cubed. You subtract, you get n squared plus f of n divides n times n squared minus 1, right? This is good, I believe. Yeah, this is n times n plus 1. And now what n do you want to pick? This is n times n minus 1 times n plus 1. Now, if you pick 1, you'll get, this is true, if you pick n is equal to 2, you'll get 2 plus f of 2 divides what? It's 2 times 1 times 3, 6. It divides 6. So this can be either 3, or actually, wait, am I wrong? I think I'm wrong with 6. Oh, it's minus, right? So this is, wait a second. Oh yes, my problem was this is 4 plus f of 2 divides 6. And now from here we get that f of 2 is equal to 2. And now with that in mind, what we also have is that m squared plus 2 divides m f of m plus 2, which is nice. But on the other hand, we also have that 4 plus f of n divides n plus 4. And we also have, as before, we have that f of n divides n. Now this severely limits what f of n can be. In fact, this implies that for every prime greater than 5, f of p is equal to p. So for any such prime, we have this. And now the only thing we do is we plug in m is equal to this prime. And then what you will get is when you plug it in the original equation, which is somewhere on this paper, yeah, here. If you plug in m is equal to prime and put n to be some number, well, you'll get p squared plus f of n divides p squared plus n. Subtract 1, p squared plus f of n divides p squared cancel out, n minus f of n. And now again, make p squared huge, make the prime very large with respect to n, and you're done. This implies that this must be 0, so n is equal to f of n. And it's using, like both of these approaches use a similar strategy, which is, if you have f of x is x for infinitely many numbers in these types of divisibility problems, you can sometimes, pass to all of them from there. Also shows you can play around, you can actually look at what these things could be, like how large can they be or not, and this solves our problem. And as always, thanks for problem solving.